I'm originally from Birmingham. I've been living in Graz, Austria for about 30 years. I went over as a student and never really came back. I'm going to talk a little bit about responsive data visualization. I'd like to invite you to go to this URL here with your devices, because hopefully the slide deck is also responsive. And you can try out the various things. You can type in that URL down here. You have to at least get to talks because the home page has nothing on it. So you have to get past talks and then you should be able to click through to this as well. Just check that it does work. Log itself out again. A moment, I need my password. Let's give you time to type in the URL there. So you can follow along like this too. Responsive web design sort of started around 2010. This is an article by Ethan Markup. A year later he came out with the first edition of his book. There's now a second edition. There are many books now on responsive web design, various aspects. I suggest you check out those two by Ethan. The idea is that, for me, it's in sort of three parts. So we want the layout of the website to respond, to adapt dynamically. We want the content elements, the images, the graphics, the visualizations, tables, all kinds of content elements, adverts even, to adapt, typically to the size, but also to other things. So the resolution, the characteristics of the display device. So that includes the interaction. That also has to be responsive. And there are two sort of extra things that are good practice. We should do progressive enhancement. So that means doing what can be done in HTML in HTML. That's the structure, if you like, the underlying structure of the content. And then styling in CSS, and then adding stuff in JavaScript, typically the interactivity. So you don't always have to use JavaScript for everything. And in some cases, JavaScript can fail. So it makes sense to have as much as you can, or have some sort of fallback just implemented in HTML and CSS. And then add selective support for extra stuff. And the second is content parity. That means that your users, they don't want to have the feeling that they're missing something, typically on the mobile version or on a smaller device. There may be sort of less stuff, and they think they can't get to some things that are present on the full-size website or the full-size device. So even if it takes a couple of clicks more, make sure people can sort of get everywhere. The Boston Globe was the first responsive website. So here it is in today's incarnation, and you can tell a responsive web designer, the first thing they do is grab the right-hand side of the browser window and move it left and right. So we're going here from a 3-column layout at around this breakpoint switching to a 2-column layout and then to a single column layout, which is obviously then much longer. And that's the essence of responsive design, at least in terms of screen widths. We design in sort of components and then we relay out between the breakpoints. So we often express that as designers in a breakpoint diagram. Here I have 2 breakpoints at 40 and 60 rems. Note I'm using rems and not px. So we're switching from a sort of a mobile first point of view. We consider the narrowest design first, and then think of it bigger, and then think of it bigger, and then we maybe think back down again from the largest, the widest down to the narrowest, and check that all our designs sort of make sense. And we'll mock them up in the browser typically and try them out. In my class, I'm a university professor, so my students are absolutely forbidden to use pixels, px units, or any absolute unit. We use relative units, so ems and rems in CSS, percentages sometimes. And for the graphics, we use vector graphics wherever we can, because vector graphics, SVG, will scale fluidly. Between breakpoints, we want things to be scalable. And at the breakpoints, we actually change, we reflow or reformat the layout. Okay, this technically is how we do it. We use media queries, which have been around now since about 2009 or 2010. So it allows us to divide up our CSS into blocks and have certain blocks of styling apply only at certain screen widths. And specifying these not in pixels but in rems allows us to take account of when the user resizes their font. So if I whack up my font to 150% or 200 as the user, then I want the layout to reformat and everything still to work. If I design in pixels, my laptop here is a UHD screen, so it's got 3,800 pixels wide. And if I'm designing a fixed width, 1,200 pixels, it's going to be all squashed up in the top left-hand corner of my screen. So it's also possible to use media queries with SVG, and it's not quite as well known as using media queries with standard CSS for HTML. So a couple of demos here. The demos should also work on the devices. Let me know if any of you have an issue. So this is a logo, and if I click the size here, at some point these lines are going to disappear, sort of around there, somewhere at that breakpoint. And you'll notice the outer rim is also getting a little bit thicker, so it's still visible at shrunk down sort of sizes. And if I look at the source code here, this is all in one file, so we're not putting anything in. The magic, so the actual drawing is the SVG down here, and the magic is in the media query up here, where I'm saying that the low width of 20 ems turn off a couple of things or change things in some way. And in terms of visualization or graphics, we can do the same thing. So I've embedded a media query inside this line chart, so that at a certain point, the fonts will get bigger, the line will get thicker in this case. You can do whatever you like, of course, right? This is just to demonstrate the principle. So we can embed these kind of changes inside our purely SVG graphics as well. Okay, responsive interaction then is what users can do, how they can interact. So, for example, on a touch screen, our fingers are generally bigger and thicker than the mouse pointer. So we'll want to increase the target size for our tapping, for our interaction elements. And we can do that just by drawing sort of invisible boxes around them. just to make them not visibly necessarily bigger, but at least the active area where we can tap can be bigger. If you're on your devices, the slide deck, you should be able to swipe through the slides. You should also, if you're looking at it flat, if you tilt, that should also go back and forth, because we have some JavaScript built in that will monitor the device orientation and the rate of tilting. And if you shake, it should go back to the first slide. So there are ways of responding to the characteristics of the device. It's not just touch. Sometimes you have a keyboard and you want keyboard support if you have a keyboard. So sniff or detect the features that the device supports and then sort of selectively add in that support. Typically you'll do that in JavaScript. So talking about data visualization now, I like to differentiate between what I call scalable visualizations and responsive visualizations. So scalable will scale fluidly, so you can make it as big or as small as you like, and it will still look as nice as it can with scale, it won't pixelate. But responsive does more than just be scalable. We have breakpoints, and we actually change things at the breakpoints. So we scale fluidly between breakpoints, but we change stuff at the breakpoint. And also we have interaction. So we take care of the different kinds of interaction that are possible. We sniff for those features. There's a great JavaScript library called Modernizer, which allows you to say, does this device have a keyboard? Does it support touch? And then depending on what it supports, you can provide that functionality selected. So I've got 4 examples now of typical graphics or charts and visualizations. And I'm going to show you some of the things that we've thought of as to how to make them responsive. This doesn't cover the whole sort of gamut, but we'll give you some ideas of what to do, or what you might want to consider doing. Let me show you the demo first. So this is a line chart. This is built using some D3, so it's based on SVG. Notice that the labels at the bottom on the x-axis are thinning out if there's not quite so much space. And then at a certain, in this case, screen width, we're making a change. So we're going to a spark line, as we saw earlier today. And at larger screen widths, we'll go back to the graphic. You can also think about data density. If you have like 20,000 points in that kind of line chart, there's no point shipping all 20,000 points to the browser if you're only going to display it at a very narrow width. So you may want to sample some of those points out and ship a much fewer number, or at least display a fewer number. But always be careful when you're sort of hiding or reducing or sampling data, because if the user wants exactly that data point, then obviously if you turn it off, they might not be that happy about it. So second example, bar charts. Again, this is built with some D3. So we can start rotating the axis labels. So we can actually shrink this. So as well as being fluid in terms of the actual bars, we can rotate the axis labels and save a little space and still make it usable at very narrow widths. Or we can switch to a horizontal bar chart, something like this. So we could set a breakpoint and at narrow widths, we could just flip from having vertical bars to horizontal bars, because we're almost always able to scroll down, and then we can pack things in vertically that we couldn't necessarily horizontally. I have seen in one of the books I'll mention in a moment some advice about actually removing some of the bars. And again, that's sort of taking stuff away from the user, so that there's an issue there with content parity. So I'd be careful about doing that. There may be some circumstances in which you want to do it, but perhaps not always. All right, let's look at scatter plots. Yeah, we'll show the demo first. So here I have to select my dimensions. This is the classic serials data set. This should also work on a touch screen if some of you are trying it on touch. If you look in this data set, you notice that the ratings tend to be slightly higher for low sugar content. It's one of the characteristics that you can read out of this data set. But how can we make it a little bit more responsive? Well, one of the issues, especially at very narrow widths, is selecting data points and zooming in. So of course we support mouse zoom, and that should work on your touch devices with pinch and zoom. What else can we do? We have here, let me first of all turn on the grid to make it sort of clearer what's happening. Okay, you're probably going to have to look at the TV on this one. We can superimpose a fisheye, and we can make that a little bit bigger. And that will distort in a local area the points, so I can then get a better handle on things that are overlapping or obscure. Or probably I find a bit more useful is Cartesian. So it sort of follows the mouse around, it just spreads out locally the space in that local area. So again, you get this sort of local zooming effect. I should probably put the tooltip here as the name of the serial rather than the record number. Disambiguation, let me turn this on. It's a little bit buggy, as I discovered last night that my students haven't really produced production-ready code. So these are slightly hacked together. But the demos are all online, and you're welcome to do view source if you dare. So with disambiguation, no, I need to get some overlapping records. Let me do sugars against sugars, and some of these should now be multiple. So there are multiple data points all on top of each other. And so one thing we can do is just list them, or another thing we can do is sort of splay them out a little bit. This is not a perfect implementation, but you get the idea. Especially if you're sort of lacking in screen space, this might help a little bit. There's a really good talk at OpenViz 2013 by Gabriel Florid from the Boston Globe on responsive scatter plots, where he mentions some of these ideas and some others. And for using scatter plots with touch, there's a nice paper at AVI 2014 reference there as well. So a slightly more sophisticated example using parallel coordinates. So one of the classic information visualization techniques. Can you see that on the TV? Oh, yes. Screen. So here, this is the cars data set, another sort of classic multidimensional data set. And each car is a polyline. There are 6 vertical dimensions, characteristics of cars. But if I don't have space, I'm going to sort of maybe get rid of some of them. So at some point we have a breakpoint around there. And we've switched out one of the dimensions, and we're going to switch out a couple more. But I always want the user to be in control, so the user has to have a way then to be able to sort of override that choice and switch them back in again. And once the user's taking control, we then no longer will get rid of them, and the user is now in control, right?
The dimensions button is not showing up on a tablet.
Ah, thank you. Maybe you can tell me later exactly what device you're using.
Okay.
Let me just check it here. It will only show up if the screen width is less than the breakpoint. And at least on my tablet, I don't have a way to make the browser window shrink. But maybe
orient it. There it showed. If I orient it, it shows.
Ah, okay, right.
There we go. All right. Cool.
Ah, it's there on mine. So maybe that is a device or a browser-specific issue. It's kind of tricky to get this stuff working everywhere, right? You really need to do some testing and try everything out. There are a couple of books that have just come out. The Christoph Kerner's book is the one that I recommend you buy if you're going to buy a book. He starts with a little bit about what responsive web design is, then goes into how to build stuff in using D3. But he also then goes on to talk about putting together a build system. So using tools like Gulp or Grunt, and how to do testing, how to do unit testing and integration testing, and sort of the whole process around building this kind of responsive visualization. It's much less now about web design, it's much more about software engineering. And it's about programming in JavaScript and doing proper software development. I have both books with me if you want to take a look at them a bit later. I just wanted to mention that there are alternatives. You don't have to use D3. D3 is great for fairly simple visualizations, up to a few hundred items. If you have many thousands of items, it gets pretty slow. So D3 works using SVG, and SVG is stored as nodes in the DOM in the browser's internal data structure. And if you get more than a few hundred extra nodes, it starts to get slow. So the fastest way, if you have thousands, tens of thousands of items, is to use WebGL. I recommend you take a look at, there are a couple of libraries that help you build stuff. Pixie.js and 2.js, which is the cut down version of 3.js. And they both allow you to build sort of 2D visualizations. They will map either to Canvas or to SVG or to WebGL, and you can flip those dynamically. And if performance is an issue, that's probably the way you want to get it. We had a paper on this at Eurobit. So that's what I have for you. Thanks to my students who helped pack together those demos. And there's my contact info. Thank you.